Hi students, today we'll learn one conservation of linear momentum and what is meant by linear momentum. So before that we'll observe on this video, right? So just observe it and it will lead to the conservation of linear momentum. Also we'll discuss why it is happened like this. No, we'll see once. This person is walking, this is not moving onto this, but he will come and stands onto this one. See here. Again you can see it, no, one more situation, no. Suppose this is one plank is there which is raised now, and he will stand onto this, then he will move to one end to another end. See here. Then what happened to this plank? No, therefore it is going back. Why? Right? So this concept can be explained by using one topic that is called linear momentum. Linear momentum and its conservation. Also we will call it as like a impulse. Also we will see the topic in this one. No? Right. So first let us go for what is linear momentum. What is momentum? Right? If you know it, no, just please comment it. So what is momentum? No? Suppose one object is going, therefore how much amount of motion is there on that object now? Like one car is moving now, therefore so it is having certain amount of mass and it is moving with some speed onto this. So therefore at that instant, no, how much amount of motion is there in that car, no, we can be calculated with the momentum, right? So linear momentum means it is translator motion, no, it is going from one place to another place, no, we will call it as like a linear motion, no. So therefore linear momentum can be defined as linear momentum. So can be defined as, so here denoted as P, that is nothing but a mass into velocity. So linear momentum is defined as like mass into velocity. Is a vector quantity or scalar quantity? So therefore linear momentum is a vector quantity. Therefore momentum is equals to mass into velocity. So the momentum direction is along the velocity direction. Therefore the object is going in which direction? No, in that direction the velocity is there. No, in that direction only the momentum will be there. No, it is a vector quantity. So can you tell me what is the SI unit of this one? No? SI unit, therefore mass is nothing but a kg into meter per second. Also therefore dimensional formula can be calculated as, therefore m1 L1 T minus 1. So dimensional formula. So therefore it is having it is a vector quantity. It is having a direction in which the object is going, right, velocity, no, in that direction only the momentum is there, no? Right. So we can have some simple concepts onto this one, no? So one more concept, no. Suppose, see here. Now, so we can define like a change in momentum. What is a change in momentum? No, change in momentum. What is meant by change in momentum? No, so change in momentum. So if suppose if an object is going with certain amount of motion, so if you exert the force, definitely what will happen now? So the speed of that object will increase, that means momentum will increase, or the speed of the object will decrease, that is nothing but momentum will decrease, or it will change its direction, no. Therefore so momentum direction is also changes on this. Clear? So in this case we can calculate the change in momentum, no. Change in momentum formula is nothing but a final momentum minus initial momentum. So this change in momentum also you have to take into the vectorially. In the vector form only you have to calculate it now, right? So just as I told you, no, change in momentum, it will take place if there is only the force is acting for certain amount of time. So therefore we can relate it. So force and change in momentum relation, no, we already studied in Newton's laws of motion. So what is Newton's second law? What is Newton's second law? That is nothing but a force is defined as rate of change in momentum, that means change in momentum by time. Change in momentum by time, not momentum by time, change in momentum by time. So therefore, the force which is acting on this object is also, it is defined as like a change in momentum by time now, right? So change in momentum, final momentum minus initial momentum by time, clear? So this already we studied in Newton's laws, no? So here, now we will define impulse. What is impulse now? Impulse momentum theorem also we can call it, no? Right? Impulse is nothing but a certain amount of force is acting for a short interval of time now. Like suppose in the cricket now, in the cricket, suppose one ball is coming and hitting to the bat, and that ball, no, it will go in different directions now. Therefore, that ball is in contact with a very small amount of time with the bat, no, but it will create like a large amount of force. Therefore, impulse is defined as a large amount of force which will be acting for small amount of time. So from this formula you can rewrite it as force into time, no. So you can write down, therefore change in momentum, that is nothing but a final momentum minus initial momentum. So this is only we can call it as impulse. Impulse, if they are asking any time, no, you can multiply with the force and time, or you can calculate the change in momentum. That's why you can able to calculate this impulse now. Therefore, the unit of momentum and the unit of impulse is also both are same. So because impulse is nothing but a change in momentum only. So also you can write down Newton, force into time, no, Newton into second. So impulse and momentum both are in same only. That means change in momentum is equals to impulse. Therefore, unit wise and everything it will be the same. Clear? So these are the concepts, no. So we can use it. So here we will discuss about the conservation of linear momentum. Very, very important, conservation of linear momentum, right? Now we will go for law of conservation of linear momentum, right? Let us write down conservation of linear momentum. Very important concept for your JEE mains and NEET, no. Most of the times in this concept questions are asked now. Let us see. So what will be the conservation of linear momentum now? If suppose external force, if there is no external force acting on the system, that means external force is not acting. If there is no force, what will happen now? Momentum will not change. Yes or no? So that means as long as if there is no force is there, the momentum will be remains constant. That means, so here if external force acting on the system is 0, therefore change in momentum will be also equal to 0. That means final momentum, so minus initial momentum, so will be equal to 0. That means total initial momentum it will be equal to total final momentum. Clear? So the momentum will remain same. That means if an object is say what is this one now? In the space, no, lot of asteroids or some lot of objects, no, they are continuously moving in the space, no, right? So therefore the speed of that object, no, like asteroids onto this one, no, the speed of the object will never change. So until there is no external force acting on the system, it will goes on with the same speed. That means if you go to the space and if you throw any object with some speed, no, so throughout its lifetime, therefore it will go with the same speed only. If there is any other object will come and collide, or any other earth, no, it will be attracted, no. If there is external force act, no, then only the momentum will change. If there is no external force acting on the system, so the momentum will not change. Clear? So this lead to the conservation of linear momentum. Clear? So we'll do the applications based on this one, no? Like we shown in the diagram, I mean in the video also. So it is version based on the conservation of linear momentum. Clear? So even you can see some more examples, no? Suppose mostly therefore the army people and those who are firing the bullets, no, so they will keep the gun on the shoulders. So they will keep the gun on the shoulders and they will fire it, no. That why the bullet will come out onto this one, no. So that means initially the gun and bullet was at rest. Therefore we are provided the momentum to the bullet. that much amount of momentum will be regained by the gun. That's why the gun will go backward. So therefore, to handle that force, no, that recall speed or recall force, no, reaction force, no, so they will keep the gun on the shoulders and they will fire it onto this. Clear? So this is also one of the example of our law of conservation of linear momentum now. Clear? So even this this plank and the person onto this one, no, that type of questions also we will do it now. Clear? So now let us see some concept here, no, some applications, and even some explosion is there. Now suppose one object is there. So here this one bomb is there, no, one object is there. Therefore initially it is not moving. Therefore initial momentum it will be equal to 0. But what will happen now? After certain time explodes. So exploding it takes place now. Explosion is because of due to the internal forces, not external forces now. This conservation of momentum does not affect now by the internal forces, because internal forces will not make an object to move on to this. Clear? So due to internal forces, no, this one, if it is suppose it is breaks into two parts now, what will happen now? Definitely these two parts now will go in a opposite direction. Therefore it is having m1 and is having m2, therefore v1 and v2. So why initial momentum was 0, compulsory final momentum also should be equal to 0. That's why these two objects, no, it will go in the opposite direction now. That means m1 v1 plus m2 v2, it will be equal to 0. Clear? In this way, so we will use always this concept, no, therefore to solve the problems onto this. Clear? Now let us see. I will show you some more examples here, no, some more examples. So please watch the video here also. So therefore we will observe lot of examples now, even the boat concept onto this gun concept onto this one now, this explosion concept, no. Also I will try to show the video here, no. Please try to watch it now. Then we will go for the questions onto this. Clear? Now let us see. Okay. I am telling you, therefore if you really want to learn the physics, no, therefore you have to be thorough with the concept clearly, and also you need to apply for the problems now. Then different models, different concepts, no, different problems, no, will make you concept ways will be very clear. Clear? So here let us do one simple question, no, here. From every problem, no, you will be having some learning things, no. Let us see. Here it is given as mass is given, no. Therefore here mass is given. Mass is equals to 2 kg. Clear? So initial speed is given, no. Initial speed, that is nothing but 5 meters per second. Clear? So the force and this time graph is given now. See, any time if you have the graphical question, so from the graphs, no, you remember that only two things can be calculated. One is area, one is slope. Clear? So therefore here force and time graph it is given, no. Therefore force and time graph. So how to calculate now? So we want to calculate final speed now. Therefore you have to calculate the area, slope. But if you are calculating the area, what you will get it now? So area means what? Y coordinate into x coordinate. If you multiply force into time is nothing but impulse. Impulse is nothing but a change in momentum. Right? So we want that only final speed, no. So therefore compulsory we have to calculate the area. That means, so therefore, so impulse is nothing but a force into time, that is nothing but a area under Ft graph. Also we will get it as like a final momentum minus initial momentum. Clear? Here one learning thing is we learned, no, that is what, if you find the area under force time graph, no, you will get a impulse. Therefore we can calculate the area under Ft graph, no, we will get it as like a impulse or change in momentum, no. So first now we will calculate area under this one, no. So here one simple way we can go for this one, no, that is it is nothing but like a, looks like a triangle here now. What is the triangle area now? What is the area of the triangle? 1 by 2 base into height. This base is how much now? 2 into height is how much now? 4. So therefore it will be 4 Newton second only, therefore here this area is nothing but we got it as 4. Here this is looks like a rectangle onto this one, no? So therefore this area, so this difference how much, no? 4 minus 2 is nothing but 2 into this height, no? 4, that is nothing but 8. So this area is nothing but 8, right? And this part of this one, no? Therefore here this part of this is looks like a trapezium. So we'll try to use all the different formulas, no? So that you will be also get remain triangle, rectangle. So this it will be your trapezium. Trapezium, what is this formula? Here also you can use triangle sign this one, no? Why you have to go for all this? Therefore, so a plus b into height. You can remember this 1 by 2. A plus b means nothing but sum of the parallel sides. Which are parallel sides? No, these two are parallel sides. That means this is your height, that is nothing but 4, plus this is your height, that is nothing but 2.5 into height is how much, no? Height means the distance between the two parallel sides is nothing but 4.5. 4 minus 4.5 means nothing but 0.5. 0.5, this is 0.5. How much it will be? 0.5 means 1 by 2. That means 1 by 4 into 6.5. So 6.5 by 4. Clear? So now here this area we can calculate it, no? This area. So it looks like a square of this one, no? Therefore here 6.5 minus 4.5 is nothing but 2. So this height is nothing but 2.5. So 2 into 2.5 is nothing but 5. So total area how much you got it, no? Total area you can get it as 4 plus 8 plus 6.5 by 4 plus, therefore it is 5. How much it will be now? This is 12 plus 5, therefore 17 plus 65 by therefore 40. Clear? Right? 65 by 40, therefore 17 nearly 1.6, no? So 1.65, therefore here it is 18.6. Therefore this it will be a Newton second. This much amount of area I got it now. But I don't want this one area, I want final speed, no? So change in momentum, how much it will be? This area, you can rewrite it as, so this it will be equal to change in momentum, mass into final velocity minus initial velocity. Clear? So mass is how much now? Already you know it, no? 2 into final velocity minus initial velocity is how much, no? 5 meters per second. 5, it will be equal to 18.6. So v minus 5, 18.6 nothing but 2, therefore 9.3. V is equals to 5 plus 9.3 is nothing but 14.3 meters per second. Yeah, therefore here you got it as nearly third option will be your correct answer now. Clear? So in this question, no, your learning thing is what? Therefore area under force and time graph, no, you will get it as impulse, that is nothing but a change in momentum. No. Clear? Like that you should note down each and every question, right? So like one point, no, you will understand in this. Now let us see. So in a given we will do this question, no? Position time graph. This is given as position time graph, right? Position time graph and distance time graph. So distance time graph, okay. So the mass is given. What is the mass of this one? No? That is nothing but 0.1 kg. The impulse in 2 seconds. What is the impulse in 2 seconds? No, 2 seconds. Therefore impulse means change in momentum. Correct? So therefore impulse is nothing but so change in momentum, final momentum minus initial momentum. Initially the particle was at this point, not to this one, no? Right? Therefore at this point it is there. So for here he gave the position time graph, no? He is asking the impulse after 2 seconds here now, right? Let us see here, no? So here we should not calculate the area. Why? Because here distance into time, so will not give any information now. But a distance by time, you will give that like a slope. Slope is nothing but a speed. So here you have to calculate the slope. Slope of distance time graph, no, you will get it as like a speed. Clear? So that means here we want to calculate the slope now. Like that, you should have the analysis onto this one. No? How to calculate the slope now? This is 0, 0 here, therefore 2, 4 here. Clear? 2, 4. Therefore, slope, what is the formula? Slope is equals to, therefore, speed is equals to, therefore, here, nothing but a slope. Slope is nothing but a, so y2 minus y1 by x2 minus x1. Suppose this is your x1 y1 and x2 y2. So 4 minus 0, 4 minus 0. Therefore, here 4 minus 0, 2 minus 0, therefore 2 meter per second. At this point, it is having the velocity, so 2 meters per second. So he is asking impulse at 2 seconds. Therefore, initially he is having this much amount of momentum. No, what is the initial momentum here now? Initial momentum is nothing but mv. How much it will be? Mu. Therefore, here 0.1 into 2, therefore 0.2 kg meter per second. Clear? Initial momentum is there. So we want to calculate final momentum. Final momentum is what? Here after that one, no, it is going in a horizontal one. No? Horizontal. So horizontal means what will happen now? Does not have any slope. Therefore slope, so it will be equal to 0. That means final speed it will be equal to 0. That means final momentum will be equal to 0. So therefore here we can rewrite it as final momentum is 0 minus, therefore 0.2. So therefore minus 0.2 kg meters per second. So minus 0.2, second option will be your correct answer onto this. Clear? In this way, you can solve the problems onto this one. No? So here learning thing is what? Therefore slope of distant time graph, no, you will get it as speed. Now we will do this question here. No? Let us see one more concept. No? See here, the wagon weighing about 1000 kg is moving with a velocity of 50 km per hour on a smooth horizontal tracks. A mass of 250 kg is dropped. See, what is this one now? This is water, right? See here, in introduction I showed one video, no? Therefore here already this is one wagon, it is moving on to this. So this wagon, let us see here, no? This wagon, this is going already with some speed, that is nothing but a 50 km per hour. What is the mass of this one now? Mass it will be equal to 1000 kg. Correct? So therefore suddenly it is dropped. Therefore here one object is dropped. So how much it will be? 250 kg it is dropped onto this. So when it is anything added now, therefore what will happen now? Will it go faster or slower? Right? See, if you are going already, suppose something is again object is came and fall on you, you will go more than your speed or less than speed. So definitely you will go with the less speed only. So therefore how you can calculate now? Therefore here dropping, there is no external force onto this one. No? Therefore initial momentum will be equal to therefore final momentum. Clear? So initial momentum is how much now? Initial momentum is nothing but initially, therefore it is 1000 kg, it is going with speed how much now? 50. Now later on what happened now? Both of this one is added here, no? So now both combinedly they are moving, no? Therefore 1000 plus 250 going with one speed here, no? So V is equals to 1000 into 50 divided by therefore 1250. Here we can solve it, no? Therefore here 0 0 5 1 25, therefore 25 ones are 25 40, therefore 40 kilometer per hour. So 40 kilometer per hour, so will be your the speed of this combined system. No? Clear? So now let us see. So one more concept, no? One more question, no? Right. Here just now I told you, no? Therefore the bullet and gun, no? Therefore exactly the same. So a man fires a bullet, right, of mass. Therefore what is the bullet mass now? Bullet mass is nothing but 200 grams now. So at a speed of 5 meters per second, the gun has 1 kg mass here now. So by what velocity the gun will rebound back? So very simple concept now. So suppose this is one gun is there now. This is one gun, right? Mass of the gun is how much now? 1 kg. So there is a one bullet is there no. This bullet mass is how much now? So 200 grams means 0.2 kg. Initially this gun and bullet was not moving onto this. That means what? Total initial momentum was 0. But finally what will happen now? So finally, therefore this gun, right, will fire say one bullet. Therefore this bullet it will be going with a certain amount of velocity, you know. Suppose it is u. Therefore here it is provided some velocity, therefore some momentum is there. So therefore it is going back. So therefore this gun it will go back with certain velocity. This is called like a recoil velocity of your gun, right? This is your velocity of your bullet, right? So this triggering, this you are triggering this one, no? So many times, so many students know what they will tell, sir, we are triggering, we are applying the force, no? No, we are triggering means what? Just we are releasing the bullet, or how the bullet will be there. This is one bullet means, so backside fully chemical will be there, something it will be and it will hit onto this. So due to burning, therefore this bullet will come out onto this. So see here, you are giving very less amount of force, but the bullet will comes out with a greater speed. That means that much force is enough to make the bullet to go that much faster? No. Therefore here that means no external force acting on the system now. So external force is 0. Therefore what will happen now? Initial momentum was 0, final momentum also should be the 0. So that means, so this bullet is having some momentum, same amount of momentum will be there for the gun onto this, right? So therefore momentum of the gun, therefore, so here final momentum now, final momentum also equal to 0. So mass of the gun into velocity of the gun plus mass of the bullet into velocity of the bullet, this also equal to 0. So we want to calculate recoil velocity now, taken here now, minus small m by capital M into therefore V, right? You can solve the problem very easily here now. So just substitute it now, therefore minus, what is the mass of the bullet now? 0.2. What will be the mass of the gun now? 1 kg into velocity of the bullet is how much now? 5. So substitute it now, therefore you multiply it now. So 0.2 is nothing but this is 10 now. So therefore minus 1 meters per second. That means the gun will go back with a 1 meters per second. So y minus no, therefore it will go in the opposite direction of your bullet. Clear? In this way we can calculate this is nothing but a recoil velocity of your gun. Recoil velocity of gun. Clear? So recoil velocity of the gun. Clear? Here we will do one simple question now again. So same concept now. Suppose here let us take now. Therefore suppose there is a one gun is there no. So like right. So this gun, this is kept at a height of how much now? 500 meters now. Therefore here there is a one gun is there no. So this is one gun. So like mostly in the war times no, there is like a Firangi it is there no. Therefore it will be having the mass is about 100 kg and it is firing one bullet. That bullet mass is about how much now? 1 kg. So therefore it is firing the bullet. So this bullet is going on hitting onto this one now at certain distance. How much distance now? 400 meters. Now we want to calculate what will be the recoil velocity of the gun. Clear? So if you want to calculate the recoil velocity now, therefore you should require with what velocity it is projected now. You want this one now. So he did not give, you want to calculate. This is exactly like a horizontal projectile motion now, right? Horizontal projectile motion I already discussed, right? I did one video, please go through it. I will keep it at an iCard now. So go through this horizontal projectile motion. So this is nothing but a range. What is the range formula? Range is equals to u into square root of 2h by g. So range is given how much now? Therefore 400, it will be u, I want to calculate u into square root of 2 into height is how much now? 500. 500 divided by g value is 10. Therefore 50 into 200. So root 100 is nothing but 10. So 400 it will be equal to 10 into u u is equals to 40 meters per second. That means, so the bullet is coming out with a 40 meters per second. Clear? So then you can calculate what will be the recoil velocity of your gun. No? So very easily, so just now we did this question. No? It is having some momentum. No? Therefore, initially there is no momentum. No? Finally momentum will be there. So we calculated recoil velocity of the gun. Therefore, mass of the bullet by mass of the gun into so velocity. So mass of the bullet is how much now? Mass of the bullet is nothing but 1. So mass of the gun is nothing but 100 into u. What is this one now? 40. How much it will be now? Therefore, here it will be so minus 0.4 meters per second. That means this it will go with a speed of 0.4 meters per second. Clear? In this way, you can calculate the recoil velocity of the gun. So in this scenario now. Clear? So let us do one more question here now. Let us. Right. So here, right. So a body of mass m is at rest, explodes into 3 pieces. Okay, that is explosion concept now, right? So 2 of which mass m by 4 each are thrown off perpendicular direction with a velocity of 3 and 4, no? And third piece will be flown with a speed. Therefore, the speed of the third part now we want to calculate. First of all, what is given in this situation now? Let us see. Therefore, this is one explosion is there, no? Therefore, it is having mass m. This is at rest. Rest means what will happen now? Total initial momentum will be 0. Clear? So now it is exploding. Exploding means is because of due to the internal forces, no? So therefore, it is exploding into 3 pieces. It is telling the 3 pieces. Right? So 2 of each mass is how much now? Therefore, here it is exploded. Therefore, one piece is about mass is m by 4. Another piece is mass is about m by 4. So this is one is going with a, both are going with a perpendicularly. Clear? One is going with a speed of 3 meters per second and another going with a speed of 4 meters per second. Therefore, third piece how much mass it will be there now? Therefore, m by 4 plus m by 4 is nothing but m by 2, or 2 into m by 4 means m by 2. So third piece mass is about m by 2. How it will go now? These two is having some momentum. What is the momentum here now? This side one momentum is there. What is the momentum here now? M by 4 into 3. So 3 m by 4. This having some momentum now? M by 4 into 4. This side. Okay, let us write down m by 4 only. Right. Now these two are perpendicular onto this one now. The resultant momentum is like this. So therefore 4. Therefore m by 4 is common, no? Therefore that is taken out. So you will get it as taken out onto this one, no? Therefore here m by 4 can rewrite it as 4 square plus 3 square. How much now? M by 4 into 16 plus 9, 25, that is nothing but a 5. So the resultant of these two, it is about 5 m by 4 now. Therefore this should be balanced by what? Another piece now. Therefore this piece is there, no? So this m by 2, this should go with the same speed in the opposite direction. That means the momentum of these two, the momentum of this one now should be same. That means why? Because initial momentum was 0. So similarly final momentum also should be equal to 0. That means m by 2 into v is equals to 5 m by 4. Get cancel out, no? These two get cancel out, no? V is equals to 2.5 meters per second. So third option will be your correct answer. Clear? Like this. So you need to solve the problems, no? Right. Here right. Now this is one question, no? A batsman deflects a ball by an angle of 90 degree without changing its initial speed. So which is equal to 54 km per hour. What is the impulse imparted to the ball? Mass of the ball is 0.5 kg. That means what is happening now here? There is a one bat is there now. Therefore, so this is one, right? This is one bat is there now. Therefore, here one ball is coming here now. The ball is coming. How with what speed now? 54 kilometer per hour. That means 54 into 5 by 18. How much now? 6 3s are, 6 9s are, 3 1s are, 3 3s are, therefore 15 meters per second. So this ball, therefore it will be get deflected like this. Yes or no? So therefore it will be perpendicular to this one, no? With the same speed, So m into same speed, that is nothing but 15. Clear? So this side it will be m into 15 now. So therefore what will be the change in momentum here now? Change in momentum. So therefore vectorially, so p momentum is also same. So p1 minus p2. So but here vectorially you can write it as like a root of p1 square plus p2 square plus 2p1 p2 minus 2p1 p2 cos 90. Cos 90 is how much now? 0. So root of p1 square plus p2 square. Mass is same, velocity is same, momentum is also same. Therefore that is nothing but a, so root 2 into p. Clear? So change in momentum, what you got it now? Change in momentum, how much you will get it now? Root 2 into p is how much now? What is the mass of this one now? 0.1 kg, 15 kg. What is the momentum here? Velocity is how much now? 15 now. Clear? So this it will be your change in momentum now. Right? So this change in momentum is nothing but a impulse. Impulse is nothing but a, so 15s are, therefore 225 root 2 into 10 the power of minus 2, so kg meter per second. This is your impulse. Clear? In this way you can solve the problems, no? So related to this. Now let us see one more question, no? Right. A body of mass 0.25 kg moving with a velocity of 12 meters per second is stopped by applying the force of 0.6 newtons. Calculate the time taken to stop the body. Also calculate the impulse of this force now. Therefore here this is a force is given, no? Right? Right. Therefore here what is given now? Mass is given. How much now? 0.25 means 1 by 4 kg. Clear? Moving with velocity is how much now? 12 meters per second. So initial speed, no? Final speed is how much now? 0. Clear? So the time, therefore you know that force it will be equal to change in momentum by time. That implies time it will be equal to, so therefore change in momentum, that means nothing but a final momentum minus initial momentum by therefore the force. So final momentum, the final it is becoming to the 0. So this is 0. So minus initial momentum is how much now? So 12 into 1 by 4. Actually this force should act in the opposite direction. Therefore minus 0.6. Clear? Therefore 4 1s are, 4 3s are. Therefore 3 by, therefore 6 into 10. So 3 2. Therefore it is 5. So it will take 5 seconds now to stop this. Clear? 5 seconds now. So therefore also calculate the impulse of this force now. Impulse is nothing but a change in momentum. So also force into time also you can write it now. So therefore we will write down impulse is equals to force into time. Time now, force is how much now? 0.6, but minus 0.6. Time is how much now? 5. So 5 6 are 30. Therefore minus 3. So Newton into second. Clear? So this is your impulse. Therefore you can calculate it now. Clear? Directions also important now. Now let us see this question now. Therefore there is a hammer is there, hammer of mass 1 kg moving with a speed of 6 meters per second and strike the wall and comes to rest in a 0.1 second. Calculate the impulse of the force, right? And average retarding force to stop this one, no? Average retardation of the hammer. So therefore first of all there is a hammer is there. So this is one hammer now. right? So this hammer mass is how much now? 1 kg. This is going with a speed of how much now? 6 meters per second, and it is going on hitting to the wall. Therefore, this is going on hitting to this wall, and it is stops. Therefore, it will be stops. How much time it will take now? 0.1 second it will take now. Therefore, so we want to calculate impulse. Impulse means how much now? Impulse is nothing but what? A change in momentum. That means final momentum minus initial momentum. Finally it stops now. Therefore, is 0 minus initial is how much now? Mass into velocity 1 into 6. Therefore, how much now? Minus 6 Newton into second. This is an impulse. So, force, retarding force, no, force it will be equal to, so therefore minus, therefore change in momentum by, therefore time, therefore what you can write it now? Here minus 6, time is how much now? 0.1 second, therefore 0.1 means 1 by 10, no, minus 60 newtons. This is your retarding force now. So, what will be the acceleration here now? Acceleration. So, acceleration is nothing but a force upon the mass, no? I mean retardation. Force is how much now? Minus 60 divided by mass is nothing but a, therefore 1 kg. So, acceleration is equals to minus 60 meter per second square. This is your acceleration. Clear? So, try to solve the problems, understand the situation, no? It is very simple, and apply the concept now. Right? I shown this, this concept, no? This concept most of the students know, they will get confused in this one. No? This is involved with a center of mass also. Let us see. Now, here I shown the in intro video. No? Therefore, here the same mass like this. No, there is a plank is there. This is kept on the smooth surface. Now, what happened now? So here this person, no, this person, a person of mass 40 kg standing on a plank of length is how much? No. A person moves to the other side, find the distance moved by the plank. That means this he came to here. When he came to here, you try to observe, no? Therefore, if he is walking, no, this plank it is going backward direction. Clear? So this plank is going. You already saw this intro video, no? So right. So now we want to calculate how much distance it will travel this plank. Now here initially, therefore initial momentum was how much? No. 0, therefore final momentum also should be equal to 0. That implies how much now? Mass of the person into velocity of the person. So plus mass of the plank into velocity of the plank also should be equal to 0. That means velocity is nothing but what? Distance. Therefore change in distance, no? Therefore m into, therefore delta x, I mean whatever it's x1, no, by t delta t plus m into delta x2 by delta t, therefore it will be equal to 0. So delta t, therefore here this person comes, no, in that same time it will go on to this time, it will be the same. Therefore m1 into delta x1 plus capital M into delta x2, it will be equal to 0. Clear? So now let us see, suppose this is m is nothing but a mass of this person. This formula only will use it, no, to solve the problems, no. This m is nothing but a mass of the person. How much now? 40 kg. Can you tell me how much distance he will travel? Most of the students they will tell that 10 meters. Here only the wrong. Really he will not travel the 10 meter distance, no, because while he is traveling, suppose if it is here, no, so while it is traveling this plank is going back. Clear? So that means he is moving, that means plank is going back. Therefore he will be going really, but if it is fixed, no, you would have moved it at 10 meters. But here is moving, no, this plank is also going, therefore he is moving not 10 meters, no, therefore he is moving 10 minus x meters. This if you really understand, no, then it is easy to solve. Then this capital M is assumed to be like a mass of the plank, no, therefore mass of the plank is how much? No, 60. How much distance he will travel now? So you can use your, therefore he is going in a positive x axis, that's why this is going in the backward direction, no, therefore it will be minus x. So this how much? No, 0. That's all. If you are really able to write this formula, no, like this, therefore this type of problems, no, it is very easy. Clear? Therefore how much it will be now? This taken here, no, 40 into 10 minus x is equals to 60 into x. Therefore get cancel out, no, this is 2, this is 3. So, multiply 20 minus 2x is equals to 3x. Therefore, taken here, no, 20 is equals to 5x. So, x is equals to 20 divided by 5, therefore 4 meters. This is going back, therefore how much now? 4 meter it is going back onto this. Clear? Now let us see, yeah, same type of question, no? Suppose here 2 persons are there, that's all, only nothing changed it is, you know, therefore same everything, but here what happened now? 2 persons are there. Now 2 persons are there on the plank, no? This is 100 kg. So, they exchange the position, that means this person will go here, this person will go here. So, therefore, how much distance it will move now? This person for 60 kg, more mass is there, more momentum will be there, he will create more momentum onto this one, no? When he is going here, no, this will go down, when he is going here, it will go to this. Therefore, if both are same, no, therefore it will be the same, but here different masses are there, no, therefore it would have moved toward the x here. Clear? So, therefore, now you can rewrite it as the same formula, therefore m1 into x1 plus m2 into x2 plus m3 into x3 is equals to 0. Clear? So, initial momentum it will be equal to 0 based on the law of conservation of linear momentum. Now, can you tell me this person how much distance he will travel now? See, okay, first of all let us take this person now. 60 kg, how much he will travel this distance now? Suppose this is your x-axis, he is going toward this side. How much distance he will travel now? Therefore, it has to travel 10, but what he will travel now? Really it will not travel 10 no, therefore it is going back one no, therefore 10 minus x. Clear? So, 10 minus x no, therefore here okay, therefore now we can take it as this person no, he is going toward this side, therefore how much it will be now? 40 into this person he will travel not only the 10 meters, therefore he will travel more distance now, therefore 10 plus x. Clear? So, this plank what it will do now? This plank no, this plank it will do. So, this it will go toward this side no, that is nothing but a 100 into therefore x no, therefore this it will be minus here, this it will be equal to 0. We will solve this one no, take this one right, or you can write it now minus 600. So, minus of minus plus 60x plus 400 plus 40x plus 100x, it will be equal to 0. So, how much it will be now? This is 60, 40, 100 means that is nothing but a 200x. So, here 400 minus 600 means minus 200, it will be equal to 0. So, x it will be equal to 1, therefore, it will travel a distance of x is equals to 1 meter. Clear? So, in this way you can solve the problems no, very easily. Here slightly one more application here no. So, the same thing 3 persons are there here no, 3 persons. So, therefore, here if you are able to write the formulas properly, then right, you can solve any type of questions now. If you are able to listen these 3 questions now, then you will do any type of problems in this one now, right. Let us see, therefore, there are 3 persons are there, one is 40 kg, another one is 50 kg, 60 kg. So, therefore, here it is standing on the plank of mass 90 kg, which is kept on a smooth horizontal plane. If A and C are exchanges, that means A is, therefore, A and C are exchange, therefore, the position of their center of mass will be shifting. See, already I told you, therefore, here therefore, here 60 kg person when it goes to here, no, he will make it to move maximum distance. Here 40 kg person he will make it as very less distance now. So, here you can rewrite it as, therefore, this side is positive x, negative x no. So, this person is going toward this side, means what will happen now? When he is going toward this side, negative, therefore, 60 kg, right. Now, let us go for 60 kg. This person how much distance he will travel now? This is totally 4 meters long it is there no. So 4 minus x. Clear? He is traveling toward this side negative. Clear? So 4 minus x, because this is totally 4 meter, but this will go back. And this person, it will go here, no? Therefore 40 into, he will travel distance, how much it will be? So this is 4 plus x. Now this 90 kg, how much distance it will travel now? 90 kg it will travel x distance. And this 50 kg person also travel x distance, therefore equal to 0. That's all. Now you can solve this one, no? Therefore very easily. Therefore 24 minus 240 plus 60x plus, therefore here 160 plus 40x plus 90x, therefore 140x is equals to 0. So 140, 40, 60, therefore 40 plus 60, 100, therefore it will be 240x, therefore 160 minus 240, therefore 40, therefore minus 80, it will be equal to 0. So x is equals to 80 by 240, therefore here 8 1s are 8 3s are. So therefore 1 by 3 meters, therefore it will travel 1 by 3 meters now. I think you got it as full clarity onto this type of Planck person problems, no? Right, which already shown in a intro video, no? Right. Here also the same type of question, no? One more question here, but here slightly different here, no? So student will confuse, but that's all, but doesn't matter in this one, no? It's very simple one, no? So here there is one inclined plane is there, one mass is there, it is coming to here. When it is coming to here, this one is going backward. Therefore this side is going backward. How much distance it will travel here now? Clear? So this is coming downward now, doesn't matter onto this. You take it as horizontal distance here now. So how much distance, horizontal distance it will travel? This travel is the distance of L. Clear? So exactly, don't think that this shape is like this, the incline is there, angle is there, it doesn't matter onto this. Clear? So it will travel this much distance here, no? Right? Now you can write it now. So this wedge, it will go back onto this block, it will come down here. This wedge, what will happen now? It will go back. This block will really travel this much distance? No, it will travel how much distance now? M into, therefore L minus x, no? So this it will go back onto this one, no? Therefore here you can write on this side positive, this side is negative. So minus capital M into x, it will be equal to 0. So taken here, no? ML minus mx is equals to capital Mx. Taken here, no? So therefore here ML is equals to x taken common, capital M plus small m. That implies x is equals to small m by capital M plus small m into L. So this is your right formula to calculate. So the distance traveled by this wedge backside. Clear? So already I choose this one, no? X here, no? Minus x, no? Actually if you are taking plus, no? Therefore you have got minus. It indicates that go back onto this one. Clear? Now this also one same concept here, no? Same concept. Therefore here there is a sphere is there. This one sphere is rolling onto this one now, right? So now when the sphere reaches to the lowest position, no, find the distance traveled by the wedge in the horizontal direction toward this side. Clear? Now therefore this is traveling, don't bother about this curvature and onto this one, no? Horizontal distance, this side horizontally, only you have to balance it onto this. So this small m, it will travel in which direction now? Therefore distance it will travel r, not r minus x. Clear? So this wedge it will go back onto this capital M into x, it will be equal to 0. Solve this problem, you can get your answer onto this. Clear? So if you really want, you can solve it, no? Just now we solved. So m into r, it will be equal to, so taken here, no? X into m plus capital M, x is equals to small m by capital M plus small m into r. So by looking it is very difficult, no, but really apply this one, no, it is very simple. Clear? Now this also one of the application here, no, very simple one, no, let us see. Now in a gravity free gravity free room, so the mass of m1 is standing at a height of h above the floor. Okay, he throws a ball of mass m2 vertically downward with a speed u. Then the distance of the man from the floor when the ball reaches the ground onto this. See, therefore here there is no gravity here, no, suppose there is no gravity, so gravity is free space, no, therefore this person is there, this person, it is at certain height, therefore he is at certain height here. Now what he did now, this person mass is about how much now, m1, what he did, this having the ball mass is m2. Right? Initially he was not moving, therefore it is floating onto this. Clear? Now what he did now? He did, therefore this person when is at height now, therefore he thrown the ball m2 with some speed, with some speed it is u. Then if we are throwing this one now, that means he has created one momentum here, no? Therefore he will be experiencing a outward momentum onto this. Clear? Therefore when this ball reaches to the ground, therefore how much high he will be raises, we want to calculate it now, right? So therefore he provided this one, no? There is no gravity onto this, therefore what will be the time it will take now? Time taken, it will be equal to, or velocity is equals to h by t, therefore time taken is nothing but h by u. Clear? Clear? Therefore here you can have the conservation of momentum, no? Therefore initial momentum was 0, final momentum also 0, so m1, so therefore m1 u1, therefore suppose you will be going with a u1. Okay, suppose let us take v, you will go with a speed v, and this is provided with this one, no, therefore it will be m2 into u. Clear? So with what speed you will go up now, therefore m2 by m1 into u. Clear? So he is going upward, right? So therefore how much time, how much distance he will travel? Suppose he will travel some distance is h1 now till here. Clear? So now we have to calculate total height, no? It is nothing but h plus h1. So height you can write down h plus h1. h1 is nothing but a height. So distance traveled. Distance is nothing but a speed into time. h1 it will be equal to speed into time. Correct? Huh? So therefore with what speed is going upward? V is a speed onto this one, no? h1 is nothing but a, so v into time. Time is how much now? That is nothing but a h by u. So therefore h taken common, 1 plus v by u. So 1 plus v by u, therefore you can rewrite it as, so h of 1 plus, this is v by u is nothing but a m2 by, therefore m1. So taken here, no? So you can write down, therefore h into, so m1 plus m2 by, therefore m1. So this is your height, no? Total height you will be reaching at this point. Clear? So now in this way you can calculate the problems, no? See, from this one now I got one question, no? Suppose you got stuck in the frozen lake. Therefore the lake is there, it's a frozen now. What you are going to do now? Therefore it is slipping onto this. So therefore you are not able to walk, you are not able to stand, but you want to come out. What you have to do now? Suppose you have some marbles onto there, one small objects are there, some packet of stones are there. What you have to do now? That stones you have to take it as much as possible, you have to give some speed. Therefore you are providing some momentum to that one ball now. Therefore that much same amount of momentum will be gaining, you will be moving back. Like that continuously you have to throw it, so that you will go back. Continuously you have to throw it, you will be going back now. So until you are reaching to the edge of this one, no, you need to continue that. Okay. So can you think that if you don't have anything onto this, how you can come out, right? Think out. So therefore please comment it, so it will be a interesting scenario. Now let us see here, no, this also one simple question, no. Right, explosion question. No? A bomb of mass 12 kg exploded into two pieces, 4 kg and 8 kg. The velocity of the 4 kg is 24. Kinetic energy of the kinetic energy, just simple thing, no? Therefore, this is your object is there. So it is having, what is this mass now? 12 kg. So initially it was at rest. Clear? Initial momentum was 0. Explosion is because of due to the internal forces. Then what happened now? Here 4 kg, 8 kg. So 4 kg is going with a speed of 24. What will be the speed of this one now? We want to calculate. Again the same story now. Therefore 24 into 4, 8 into V. Therefore V is equals to 8, 4 1 4 2 therefore 12 meters per second. Therefore this it will be going with a speed of 12 meters per second. He did not ask the velocity, he has asked the kinetic energy. What is the kinetic energy formula? Half mv square. So half m is how much now? 8 kg. So it is 12 square. So it is 4 into 144. That is nothing but 16, 1, 16, 17, 1, 4, 5, 576 joules. No? This much amount of kinetic energy is there on the 8 kg piece. Now, we will discuss one more question. No? Right. There is a mass of 3m is at rest now, explodes into 3 identical parts now. 2 pieces will move with a speed v, mutually perpendicular, total kinetic energy. See, again the same thing now. Therefore, here it will be 3m. Initially it was at rest. Therefore, initial momentum is how much now? 0. Final momentum also should be 0. Now, what happened now? Here it is exploded into 3 pieces. M. 2 pieces are going with the speed of v perpendicularly. Again the same story now. So, this it will be a resultant now. Therefore, mv into root 2. So, this it will go with some speed v dash, m into v dash is equals to mv into root 2, get cancelled, v dash is equals to root 2 into v. He is asking total kinetic energy. Total kinetic energy means what? Total kinetic energy means kinetic energy of all the pieces. No, this kinetic energy of the piece, no, half mv square. First piece, second piece, half mv square. Third piece is having the velocity is how much? No, half m root 2 into v whole square. Clear? So this how much now? 2v square, 2 plus 1 plus 1. Therefore, it is 4mv square by 2, that is nothing but a 2mv square. This is your total kinetic energy or total energy released in this explosion. Right? We will solve some more questions. No? Let us see here. No? Right. This is also one important question. No? The heavy nuclei break into 2 fragments, no, which fly with a velocity of 27 and 1, the ratio of the radius of the fragments. Right? So, therefore, here how to calculate it now? Let us see. There is one heavy nucleus is there. Right? Therefore, it is having some mass is m. Therefore, which is at rest now. That means initial momentum was 0. Clear? So, what happened now? It is breaks into 2 parts. I don't know. Therefore, this is m1 and this is m2. Clear? This is one is going with a speed of 27. Right? We will solve some more questions. No? Let us see here. No? Right. This is also one important question. No? The heavy nuclei break into 2 fragments, no, which fly with a velocity of 27 and 1, the ratio of the radius of the fragments. Right? So, therefore, here how to calculate it now? Let us see. there is a one heavy nucleus is there, right? Therefore, it is having some mass is m, therefore, which is at rest now. That means initial momentum was 0. Clear? So, what happened now? It is breaks into two parts. I don't know. Therefore, this is m1 and this is m2. Clear? This is one is going with a speed of 27 is having the velocities, no? So, and you know that therefore, here you can, if you want to calculate the radius of this one, no? So, we know that initial momentum is 0, final momentum also 0, that means this momentum and this momentum also should be the same. So, suppose it is going with a V1 and also going with a V2, right? So, momentums are same, no? Therefore, m1 V1 is equals to m2 V2. So, he is asking this ratio, no? Therefore, m1 or m1, what you can write it now? M is nothing but a density into volume, density into 4 by 3 pi r cube into V1 r1 cube is equals to density, because same material, same amount of this one, no? So, 4 by 3 pi r2 cube into V2, this will get cancelled out, no? So, therefore, here r1 by r2 whole cube, it will be equal to, therefore, V2 by V1. V2 is how much now? 1 by 27. Clear? Therefore, it is given 27 is to 1. So, therefore, you can write it as like a R1 by R2, you can rewrite it as like a, so 1 by 27 whole to the power of 1 by 3. Or this I can write it now 3 cube. 3 cube cancel, no? Therefore, 1 by 3. So, R1 by R2 is nothing but a 1 is to 3. Sometimes they will ask you what will be the surface area of this one, no? So, ratio of the surface areas also you can, they may ask you, right? Surface area, what you will get it now? A1 by A2, area means whole square, no? R1 by R2 whole square. What you will get it now? R1 by R2 is nothing but a 1 by 3 whole square is nothing but a 1 by 9. Clear? So, they did not ask, but like this also you can expect it now. Clear? Now, let us see one more simple concept, no? Simple one now. This is very, very simple question. See, like this, if you do as much as more number of problems, no, then you will become more perfect onto this. So, let us see one question here, no? So, a bomb is at rest. At rest. Rest means what will happen now? Initial momentum was 0. So, explodes into 3 equal masses. 3 equal masses. So, with these velocities are going third velocity. Simple thing, no? So, therefore, final momentum also should be equal to 0. Therefore, m into V1 plus m, because all are identical masses, no? M into V2 plus m into V3, it will be equal to 0 factorially. So, m taken out, no? V1 is how much now? 2i plus 3j plus I minus 2j plus V3, it will be equal to 0. So, therefore, 3i, therefore, plus j plus V3, it will be equal to 0. So, V3 is equals to minus 3i plus j will be your answer. Clear? So, in this way you can solve the problems, no? So, it is a very simple question. No? Yeah. Now, one more slight important question. No? So, maximum compression of the springs. No? Right. Here, therefore, here find the maximum compression. So, compression we want to calculate. K did not given, no? Okay. Let us write down answer in terms of like a K only. Right. Here, maximum compression, when it will happen now? Here you need to have the learning thing is one is there, no? Compulsory. What is that? You are giving some momentum here, no? We are giving some impulse onto this. So, this one, what will happen now? This will go closer to this one, closer to this, and therefore, when it is closer, no? This will be also start moving onto this, but this having more momentum, further it will compress onto this one, no? Then the speed of this one is goes on increases. So, they will goes maximum when it will be happen now, when therefore, the momentum of this one, no? And when this will, right, when the maximum compression will takes place, no? So, when both are going with the same speed onto this. Clear? So, therefore, initially we are giving some momentum here, no? initial momentum is given. What is the initial momentum now? Therefore 3 into therefore 30. This initially is not moving now, 2 into 0. Therefore 90 kg meters per second. So this is your initial momentum now. Final momentum what will happen now when both are going with the same speed now, right? Final momentum what will happen now? Therefore m1 plus m2 into common velocity. How much now? 3 plus 2 into v, that means 5v. So 5v is equals to 90, that implies v is equals to 90 by 5. How much it will be now? Therefore 18, so meters per second. Clear? So now we don't want this velocity, we want maximum compression here now. Right, we want to calculate maximum compression now. Here you have to use law of conservation of energy. What is the law of conservation of energy? So initially how much energy is given now? It is having initially, that is having kinetic energy, therefore half into mass of this one, no? That is nothing but 3 into 30 square. This is initially this much energy is there. So this final energy what is happening now? Finally this both are they are moving, that is how much now? Both are having kinetic energy, that is 3 plus 2 into v square, plus also it is having some compression of this one, 1 by 2 k x square. Clear? So simple. Therefore now if we are able to write this one, no, therefore almost the problem is over. So therefore 1 by 2 cut it, no, therefore cancel it, no, 1 by 2 1 by 2 1 by 2 get cancelled, no. So therefore 3 into therefore 900. So therefore here it will be equal to 5 into velocity square, no, therefore 18 square plus k x square. Now therefore for here 9 3s are 27. So 5 into, so you can rewrite it as 324 plus k x square. So 324 into 5. Okay. So now right, therefore here 2700. So 324, therefore it will be 4 2s are 5 4s are 22. So 10 12 1 15 16 16 20 plus k x square. So taken here no, 2700 minus 1620, it will be equal to k x square, right? So how much it will be now? Therefore here 80 700, so 17,080 it will be your answer, k x square. X is equals to root of 1080 by k, so will be your answer. So therefore here there is a one very good learning is there, that is if there is connected with a spring, no, so they will be having maximum compression when both the objects are having the same speed. Clear? Then you can apply law of conservation of energy, then you can calculate the maximum compression in the spring. Two learning things, we are providing with one speed so that it will move with some common speed. At that time only maximum compression will take place now. This is one point. Then again you have to apply law of conservation of energy, then you can able to solve what are the problems here now. This is one of the greatest learning in this question, right? We will solve this problem now. Here two blocks of mass m and 2m are connected by the spring now. Initially the spring is compressed by x now and released. We want to calculate velocity of the second mass now when that comes to natural length. So therefore when it is compressed, then what will happen now? When it is compressed, therefore energy it will be stored. Then if it is released, this will go with one speed, this will go with one speed. Therefore here initially how much energy was there now? 1 by 2 k x square. Then suppose it is goes with the speed of v2, this will go with the speed of v1. Now here what will happen now? This energy will be converted like a 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. naturally no further expansion was not there, there is no other potential energy. Clear? So now we don't know what is V1 and V2. We want to calculate now what is the V1 and V2. So initially, so when they compressed here, no, so they are not moving, therefore initial momentum was 0. Then after releasing they are going because of due to this spring only, so there is no other external forces, this it will be the internal forces. Then what you can write it now, final momentum also will be equal to 0, so then you can rewrite it as m into V1 is equals to 2m into V2, get cancel out, no, therefore V1 will be equal to 2V2. Now we want to calculate this V2 only, so because velocity of this, substitute in this one, no, so what you can write it now, 1 by 2 k into x square, so 1 by 2 m1 v is nothing but a 2v2 whole square plus 1 by 2 m2, sorry, m2 is nothing but this m1 is nothing but a m, so m2 is nothing but a 2m into v2 square. Clear? So therefore here 1 by 2 1 by 2 1 by 2 get cancel out, no, therefore kx square, so therefore here 4m v2 square plus 2m v2 square, so totally kx square is equals to 6m v2 square. So v2 we want to calculate, no, v2 square taken here, no, therefore k by 6m into x square, therefore v2 you can write down root of k by 6m into x. Clear? So in this way you can solve the problems, no, so on this concept. Clear? Now let us see one more question here, no, right, a bomb of mass 1 kg is thrown vertically upward, right, we are doing now, we are throwing upward. Clear? So with a speed of 100 meters per second explodes into 2 pieces after 5 seconds. The fragment of m1 400 grams, no, moves downward with a speed of 25 meters per second, then the speed and direction of the m2. Yeah, so anytime whenever you are taking, no, you have to conserve the momentum and also along the directions. Therefore if it is along the y axis you have to conserve only along the y axis, if it is having the momentum along the x axis, separately conservation momentum along the x axis you have to do it. So now let us see analysis this question now here, very easily we can analyze, no, therefore let us see here now, this is 1 kg bomb is there now, this is 1 kg, this is going upward, it is thrown with a speed of u is equals to 100 meters per second. Clear? Therefore after time t is equals to 5 seconds, no, therefore here it is explodes into 2 fragments, no, right, at what height it is exploded we don't know, right. So and also after 5 seconds, no, what will be the speed also we have to calculate. What will be the initial momentum now? Initial momentum means compulsory you require the speed. When you throw upward, what will be the speed now? V is equals to u plus at. So V is equals to u is how much now? 100. Therefore minus g, because minus g, no, g is nothing but 10 meters per second. 10 into 5, so 50, therefore 50 meters per second. That means at this point, therefore here at this point initially, therefore when it is went to here, no, right, when it is went to here, no, therefore it is having momentum upward onto this. Therefore initial momentum is there. What is the initial momentum now? Initial momentum is nothing but a, so mass into velocity along the upward y axis. That means you can take it as like a this is your axis now, therefore it is upward, therefore j cap. Clear? So m is how much now? 1 kg into 50, therefore j cap. So 50 j cap positive. Initial momentum is 50 j cap. Now what do we want to calculate now? So after that initial momentum is there now along the j cap now. Then after this one now, what happened now? There is a one is there, 400 grams. 400 grams means 0.4. This is your 0.4 moves downward. This is going downward with 25 meters per second. 25. Right? This goes downward with 25 meters per second. Now this is 0.4 means compulsory this is 0.6 no. This will go up. So with what speed we want to calculate now? V goes upward. Therefore, these are the three options. This is first option is wrong. Clear? So again conservation of momentum here now. What is the conservation? What is here now? Initial momentum was there. Final momentum. What is the momentum here now? This is 25 into 0.4. Therefore, it is in which direction now? Therefore, minus j cap now. This is your final momentum. So, therefore, plus 0.6 into v j cap upward onto this. So, initial and final no, you have to write it no. So, initial momentum and final momentum both should be equal. Initial momentum is how much now? 5 j cap. Upward is how much now? Here 25 into 4. So, therefore, it is 100, but 0.4 means 10. Therefore, 10 minus j cap. Therefore, 0.6 v. Therefore, j cap. This taken here no. This is 10 means 60 j cap. 0.6 v j cap. Therefore, v is equals to 60 by 0.6. 600 by 6 no. 100 meters per second. That means this will go up with a 100 meters per second now. Goes upward now. Right? Fourth option will be your correct answer. Clear? In this way, you can solve the problems no? For a right. So, here also same type of problems no. Here two blocks are there, M1 and M2 are connected by this one no. The block M2 is given a sharp impulse of velocities V0 toward the right. Maximum elongation of the spring suffers. Again the same thing no. When you give this one no, therefore maximum elongation will take place only when there is it is going with both are going with the same speed onto this. So, maximum elongation only we want to calculate. So, first let us calculate what will be the common velocity of this. So, therefore, here initial momentum is how much now? Initial momentum is nothing but m2 into v0. So, final momentum is how much now? Both has to move in the same direction no? Same velocity. So, m1 into v there. m1 plus m2 into v. Therefore, m2 into v0 is equals to m1 plus m2 into v. So, v is equals to so m2 by m1 plus m2 into therefore v0. This is your right common velocity onto this. Therefore, what will be your maximum elongation onto this one now? Therefore, again you have to go for law of conservation of energy now. Initially, what was energy? Half m2 into v0 square. This is your initial energy now. Final energy is how much now? Half m1 plus m2 into v square. This is v. Clear? And also, therefore, 1 by 2 k into x square. Please solve this problem now. So, solve for x, then you can get your answer onto this in this one now. It's a simple concept no. Substitute this v value also substitute here no. Simplify. Therefore, you can calculate the x value. We already calculated so many times no. This type of concept. Just mathematics no. Just go through it. Now, we will see one more concept no. Let us see here no. Here, okay, this question is not that much clear. Okay, I will tell you. So, there is a nucleus is there of mass 218 AMU is in a free state. Decays alpha particle no. Alpha particle. Kinetic energy of the alpha particle is emitted is how much no? 6.7 mega electron volt. The recoil energy of the emitted daughter nuclei. So, therefore, here this is nothing but a alpha decay. So, we can rewrite it as alpha decay. What you will get it now? There is a nucleus is there. So, therefore, what is the mass of this one now? 218 AMU. This is here right, A, suppose some x element. What it will happen now, this x element no is splits into two parts. One is y element plus and another one more smaller element. Therefore, this is alpha, right. This is having some recoil velocity onto this one. No? This is going with a some velocity of this. It is u. But he gave kinetic energy of this, energy of the alpha particle. Therefore, see, first of all, let us write down the equation. No? 218. So, alpha is nothing but what? Helium nuclei. Alpha is nothing but 24. So, 4 you can rewrite it as 4 AMU. You can remove this one. No? Therefore, 214 will be the mass of this one. No? Clear? So, therefore, initially this was at rest. No? Therefore, initial momentum was 0. Therefore, similarly final momentum also should be the 0. So, therefore, this suppose I will write it as formula. No? Capital M into capital V should be equal to small m into small u. This is your momentum. But what about the kinetic energy onto this one now? Do you know that kinetic energy, what is the formula? Kinetic energy is nothing but a p square by 2m. So, momentum, therefore, momentum square by 2m. So, momentum can be written as square root of 2m into kinetic energy. Clear? So, here you can write down, therefore, momentum of the of your heavier nuclei. So, therefore, energy of the emitted daughter nuclei, it will be equal to momentum of your alpha. Momentum, what you can write it now? Therefore, root of. So, we can rewrite it as momentum is nothing but a root of. So, therefore, 2m is nothing but a capital M. Here you can write it now. 2 capital M into kinetic energy of the daughter nuclei. So, square root of 2m into kinetic energy of your alpha. Clear? So, here you can rewrite it as, so square it and cancel it. No? So, mass of this one, no? Mass of is how much now? 214. So, into kinetic energy of this. We want to calculate kinetic energy of your daughter nuclei. It will be equal to mass of this one is how much now? 4 AMU into, therefore, how much amount of energy is given for alpha? Alpha is nothing but a 6.7. Therefore, 6.7 mega electron volt. So, kinetic energy of your daughter nuclei 4 into 6.7 divided by 214. Let us write down this simple one. 4 into 6.7, 26.8 by 214. .125 mega electron volt. This is your energy. Clear? Like this, you can solve the problems, no? So, but you should be very clear in the concept, no? And you have to do the problems. Without the problems, no, you will never be perfect in the these concepts onto this, right? So, each and every different varieties of problems, no, you have to try it. So, from each and every problem, you will get one information, like graph is there, area you calculate, one graph is there, slope you have to calculate. So, like when springs are there, their common velocity you have to calculate it now, and applying of law of conservation of energy, right? So, like this, each and every point, no, there will be a learning point will be there, right? So, simply solving, simply copying, no, therefore, doesn't matter. So, does not give any information onto this, right? So, each and every point, no, you need to understand, you have to make one note. So, then if that type of problems comes, no, you need to apply that concept. So, then only it will be clear for you, right? So, thank you. Please subscribe to my channel. No? Thank you for watching my video.